let's focus on the second category, which is rational function, which is a fraction. So what should we do if you take limits at infinity if we have rational function? Again, we need to check the end behavior of the ratio, which is we need to choose the leading term in numerator and also divide with leading term in the denominator. So you can ignore other terms, you just take the highest power of your numerator and highest power in your denominator. Let's see this example here, limits of this function here for x approaching positive infinity. So as we mentioned before, let's take the highest power in your numerator and highest power in your denominator. So let's rewrite this back and then let's cancel out the common term. Now you have limits of 2 as x approaching infinity. So limit of a constant is again a constant. So your answer is just 2. Now let's see example number 2, limits of this function here, a rational function, as x approaches positive infinity. So let's take the highest power in your numerator and also the highest power in your denominator. So let's rewrite this here, x cubed over 5x to the power of 4. So let's cancel out the common term. So now you are left with limits of 1 over 5x as x approaches positive infinity. So now if we substitute the value of positive infinity here, 1 over positive infinity, this should be 0. Next, let's see number 3. This is limits of 9x squared over x plus 2 for limit x approaches negative infinity. So again, let's take the highest value in your numerator and highest value in your denominator and rewrite this here. Let's cancel out the common term. So now you're left with limit of 9x as x approaches negative infinity. So for this one, you can just put in the value of negative infinity here. So 9 times negative infinity, this will result to negative infinity. You can also check from the graph as well. So this is the graph of straight line of 9x. And then as x approaches negative infinity, the limit will give you the value of negative infinity. So there are 2 ways to solve this kind of question. So now let's proceed with the example 4. This is limits of this rational function as x approaches negative infinity. So let's take the highest power in your numerator and take the highest power in your denominator. So let's rewrite 3x over x squared. So let's cancel out the common term. So you're left with limits of x approaching negative infinity, 3 over x. So now let's check again. We have the rules of constant over a large number. This will result to 0. So again, 3 over negative infinity, 3 over a very large number, a very small number. This will give you 0. And finally, for example 5, this is the limits of this function here as x approaches infinity. So let's take the highest term in your numerator and the highest term in your denominator. So since you have common term, let's cancel out. So you are left with limits of x approaching infinity of 3 over 2. So now limit of a constant is again a constant. So the answer is 3 over 2.